Okay, now that we've got these tedious details behind us, I can go off script a bit and we can all relax. So let's get started with programming languages. The question everyone has been asking is, what is a programming language? A programming language is a set of instructions which dictates the flow of electrical impulses within a computer system. What is the difference between a natural language and a formal language? A natural language is a language which develops naturally over the course of many years. Examples include Spanish, English, German, Hindi, Mandarin, Chinese, Russian, etc. A formal language is a logistic system provided with an interpretation. It defines the grammar of programming languages like Python. If you're sick and tired of your language's ambiguities, content yourself with the fact that the number of natural languages is consistently declining. According to the New York Times, of the estimated 7,000 languages spoken in the world today, linguists say, nearly half are in danger of extinction and are likely to disappear in this century. So while natural languages are on the decline, formal languages are on the rise. So why doesn't a computer understand English? After all, we, the natural language speakers, are its creators. The answer to this question is very simple. If computers understood English, or any other natural language, there'd be no need for formal languages. But there is, simply because computers are not brains, and brains are not computers. Let's dive into this topic a bit more. The man you see in the top left corner is Noam Chomsky, father of modern linguistics, cognitive scientist par excellence, and significant political analyst. In his 1965 book, Aspects of the Theory of Syntax, the point is made that words are combined to make sentences like, flying planes can be dangerous. We understand flying, planes, can, be, and dangerous. Putting them together in this order creates a grammatically correct sentence. What else is there to say except that we can parse this sentence in more than just one way? Ask yourself the following question. Is the sentence, flying planes can be dangerous, unequivocally unambiguous? Let's find out. If the sentence requires extensive context in order to be understood, computers could not possibly make something out of that sentence. As aforementioned, our sentence can be parsed in more than one way. Planes which fly can be dangerous is one, to fly planes can be dangerous is another. Okay, we get it. Natural languages are ambiguous and lengthy. High-level programming languages are less ambiguous and less lengthy than natural languages. But assembly languages, also called low-level programming languages, are even less ambiguous and less lengthy than high-level programming languages. The most unambiguous and concise is, of course, machine code. Unfortunately, it'd be very hard for a human being to understand what a bunch of ones and zeros mean. Therefore, we have high-level programming languages and assembly languages. High-level languages are on top of the world. Assembly languages are second, since they're closer to machine code than high-level languages. Then comes machine code and hardware. Ladies and gentlemen, I present to you one of the dumbest hypotheticals ever conceived by man. Let us imagine that little Johnny is taking a walk. For some strange reason, he starts floating and ends up in a pit filled with binary digits. So we're going to try and help Johnny. Did I call him Johnny? I forgot. Let's just call him Johnny. I like that name. So how are we going to help Johnny? Is it with Python? Is it with English? Or is it with assembly language? You guessed it right, with the assembly language. So let us look at the differences between high-level programming languages and low-level programming languages. So high-level programming languages is fairly slow compared to its adversary. It has a flexible syntax and is very relatable to English speakers. It has a large community, so help is always available. A low-level programming language, such as assembly, has a super small community, so help is rather difficult to find. It's pretty hard and complicated to write, but it is lightning fast since translation is quickly completed. Today's million-dollar question is, what is Python? Python is a programming language. Wow, we got that. To be more specific, it is an interpreted programming language. Python is object-oriented. Object-oriented programming is a programming language model organized around objects rather than actions and data rather than logic. This provides Python the flexibility to define, create, and manipulate objects. History of Python. The man you see in the top left corner is Guido van Rossum. Hope I pronounced that correctly. Python was conceived in the late 1980s. Implementation began in 1989. According to Guido, in December 1989, I was looking for a hobby programming project that would keep me occupied during the week around Christmas. I had a home computer and not much else on my hands. I decided to write an interpreter for the new scripting language I had been thinking about lately, a descendant of ABC that would appeal to Unix and C hackers. Python's philosophy. The Zen of Python is an unofficial Python manifesto written by Tim Peters. Number 1, beautiful is better than ugly. Number 2, explicit is better than implicit. Number 3, simple is better than complex. And number 4, complex is better than complicated. Take these 4 philosophies to heart. Writing beautiful code is a wonderful thing. Simple is better than complex because you don't want to bore yourself to death with programming. Complex is an inevitable disposition. We have to live with that. The world is complex. However, rendering things more complicated than they are is a choice, and we must avoid such a choice. Who uses Python? Python has been used time and time again by NASA to control robots on Mars. It has been used in game development. EVE Online was built with stackless Python. Rocket science. SpaceX uses Python to launch rockets into space. In physics, Python is used for things like simulating physical behaviors. And in neuroscience, Python is used to simulate brain functions. Moving on, Python's popularity explained. Python is popular for many reasons.